in this video we try to explain one of the confusion that arise in partial fraction method, especially when we have repeated linear factor. Okay, so let's write it. So it's a partial fraction method, partial fraction method. So the confusion rises when we have a repeated factor, repeated factor in the denominator. So for example, let's look at a situation. So it doesn't matter whether it's linear or quadratic or any other higher ordered factors, but let's look at a situation like, for example, let's say we have 3x plus 2 over x minus 1 squared. So if we have a situation like that, what we normally do is, so we can write this as, so you know that, so normally the standard theory says that we need to write like a over x minus 1 plus bx plus c over x minus 1 squared. So you know, so the regular theory says that, you know, you need to write the numerator degree 1 less than the degree of the denominator. So if this one has the degree 2, so this one need to have degree 1. But the situation is like what we normally say, we do not do this. Okay, so do not do this. The reason is this is like unnecessary, because if you try to do that in a general situation, but you can see that this is like kind of really clear, a has to be zero, b and c, you're going to get 3 and 2. But you know, if when you have more factors, what's going to happen here? We have 3 unknown. In a general situation we have 3 unknown, but we can show that we actually do not need 3 unknown. We can write this one as just using 2 unknown. For example, instead what we're going to do, so instead we can write this one as 3x plus 2 over x minus 1 squared. If we have something like that, what we normally do is we can write this one as a over x minus 1 plus b over x minus 1 squared. So we have only two unknown, so that means it's easy to solve. So only 2 unknown, and then also, so the format is going to follow the format of the first term. So the first term has a format just a like just a constant, so that means everything else can follow the same format. So this is the reason. So so this is why we can do this. So why? So let's say, for example, let's say we're going to go with the first method and try to get something like this. Let's say this is what you get. Okay, so you're going to get 1 over x minus 1, that means a equal 1. Let's say you're going to get 2x plus 3 over x minus 1 squared. Let's say this is what you get. Okay, so you find a, b, c, and then you're going to get a equal 1, b equal 2, and c equal 3. Now you can show that you can do a little trick. So what we're trying to do, you can actually create the same like x minus 1 factor in the numerator. For example, you can rewrite the numerator of the second term like this. So you can factor out x minus 1. So if you factor out x minus 1, you're going to get 2x minus 2. So to get plus 3, you have to add plus 5 over x minus 1 squared. Now what we can do, we can split this into the second term you can split into two factors. So you have 2x minus 1, and in the bottom you have x minus 1 and then x minus 1 plus 5 over x minus 1 squared. Now you can see that this term get cancelled. So this term get cancelled, and then you're gonna simply get so you have 1 over x minus 1 is going to be 2 over x minus 1 plus 5 over x minus 1 squared. And then if you combine, you're going to get 3 over x minus 1 plus 5 over x minus 1. Now you can see that you only need two terms here. So that means, writing the fraction in the first form is unnecessary. So what I call in first form is, that's the first form, is unnecessary, because you can still get the same answer just using only two unknown. So that is the reason why we are not writing this in the first form. Instead we're going to write in the second form when we have repeated factors. I think it's clear, because we can always do this kind of simplification when we have repeated factors. So that means writing the second term as bx plus c is unnecessary, because then we have three unknown, but rather we can have just two unknown. Okay, so that is the reason why we follow this pattern when we have repeated factors in the denominator. So it doesn't really matter whether these are linear or quadratic. We can always do similar kind of argument. Okay, thank you.